Hello, good morning, good afternoon, and good evening, probably in your time. I'm sorry that I have to um, share this video a little bit late. I have a problem with my computer to do the video, but hopefully it will be no problem within today. So we are talking about, we can move on and we can talk about the optimization and on productions. Like previously, we are talking about the optimization on consumption, but for today, we will talk concerning the productions, and you have to think that you are play role as the producers for it. Okay, so the theory of optimization production, you can think that the you play role as the producer, so you are the owner, you have the company, and you have to think that you own two output, which is the capital and labor, and also it can be you are thinking that you have to find the right combinations for making or produce something, right? Produce a product for your company. So a company which has a true output and cost and with the joint production cost, so it can produce the maximum profit that we measured with partial differential methods. As you still remember the Lagrange methods, Lagrange method is very common for you as the consumer or making like measures the optimization of consumption, the satisfaction, and the second is the producer, the production, the optimization of production. You also use the Lagrange. So you have to rely on the production function. I think for previously, if you still remember, for the the consumption optimization, we will compare between two goods, right? For here, as the productions, we will using two independent variable, which is capital and also labor. So here is the function of hopefully it's still working here. Okay. This is the equations of production function. You need to remember between the capital and labor. So the capital and the labor is the equations of isoquant, and the combination of it between the equilibrium of it is the combination for production for optimum productions. So you have to recognize which is the isocost and isoquant. If you are having the combination between the isocost and isoquant, you can call it as the least cost combination. What is least cost combination? Least cost combination, it is the combination of the point that which is you can recognize which production can give you the high benefit, right? The optimum benefit, which is less cost that can produce. So this one is you can see that this is the combination of the production here, right? So the least cost combination is the LCC is between the isocost in isoquant, the isocost line and isoquant curve. So this is the LCC, the least cost of combinations. So why we are talking about this? Because in the next slide, we are making or we are measuring about this one. So you have to recognize what is least cost combination. You need to remember of the microeconomics. I have to still remember the microeconomics. The least cost combination of production is really needed. And for you as an entrepreneurs, after you graduate from UMY or now you are working as entrepreneurs, you have to calculate with when you are adding the capital and where you are adding the labor. Okay, so this is the challenge for you as the entrepreneurs or a manager of a company. So a company, if you're thinking that you want to improving your productions, like in here, yeah, you need to increase your ISO cost line. So you have to think that you need to upgrade your capital, you have to upgrade your labor. So this is the things that you need to recognize. Okay, this is the I should be the optimum will be in this side, probably in some side in here, or or if you are having the ISO cost line in here, you have to make it optimum by choosing the I2 as your ISO cost curve. ISO quant curve. So this is the basic theory for next that we will talk about optimization of productions. Okay. Okay, next we will talk about the equilibrium of production. We are talking about the equilibrium production. Still remember we have the ISO cost budget line. The ISO cost budget line, we need to recognize how much capital that we had or how much income that we had. It's assigned by M, and M can be calculated or equal to capital um, times to price of capital plus labor times of the price of the labor. So you will find the combination of the optimal level. So to measure it, we have to use the Lagrange method. I hope you still remember on the mathematics first, and also previously that we also have with Mr. Fitra, right? You still remember the function, the production function here. We're having the F plus Lagrange, right? Lagrange multiplied by the function of the budget line equation or ISA cost equations. This one is to measure the combination, production combination for optimum level. So you have to if you are working as the managers or entrepreneurs, you have to know about Lagrange very well, because this one is like the answer, the analysis tools, when you have to recognize which combination of production need to be highest, make the highest or make the optimum level. So this is a very useful for you if you are working after this to be an analyst or if you be a manager. For example, if you want to maximize it, like previously we have the equation of Lagrange. Now we are thinking, we have to make it differentiated. We have to differentiate it by the K and by the L. And you will have this one. The equation 1 and 2, you have to make it like Lagrange is equation to Lagrange. The Lagrange of K like equal to Lagrange of L. So this one can be measured how much is K and how much is L, the capital and L. The marginal product, and again, after you understand the Lagrange, the optimum level, you also have to recognize about the marginal product. How to measure the marginal product? You have to differentiate between the production function, between the K and also the L, right? In here is the K, this one is the L. So in this part, you already recognize, right? The marginal utility is the additional of utility for capital and labor. How much is the additional of K and L can be impacted to the optimum uh, production function. Okay. Okay, we will talk more. Now we will do the example of the mathematics using the problem here, right? Okay. If we have the function production is 6K, it's 1, 2, and 3. Okay, please form the marginal product. Yeah, okay, we are asked the question is how much is the marginal product for K and marginal product for L. We already have K is equal to 8 and L is equal to 27. Okay, what is the marginal product for K? Now you need to think that how much is the differentiation of K, right? This one is K, this one is K. How much is it? You have to differentiate. 6 multiplied by 2.3 K to per 3 minus 1 L 1.3, right? So how much is it? It's 2, so 4K seems like minus 1 per 3 L 1 per 3. Okay, this one is the marginal utility or marginal product for K. Since we already have K equal to 8, L equal to 27, we can put it in here. 4 times 8. Okay, and this one is 27. Okay, this one. So you can measure it by yourself using the calculator, or you can measure it after that. So this is the the MP for K. How about the MP for L? Okay, I think after this I need to save it. Please give me 4 seconds. Okay, thank you for your time. I'm already recording it because after this we will move into the next slide. The next slide, okay, we're measuring about the L. Okay, this one we have the FKL is 6K, right? This one, which is K is equal 8 and L is 27. We already have the K, right? MP for K, we already have it, and we will measure the L. It's also the same. Have to be oh, sorry. Okay, we need to make it quick. Okay. Okay, we have to differentiate it from this to L. Okay, 6, we already have 6.13, K 2.3, K 2 per 3, L is 1 per 3 minus 1. Okay, so this one will be 2K to 3L will be minus 2.3. Okay, this one is for the marginal product of L. The marginal product of L, and then we can put this one. K is 8, L is 27. Now please measure 2 times 8, 3. Sorry, this one should be 27. 27. This one is minus 4. Okay, you can calculate it. So you already have the MPK, the marginal product for K, and also marginal product for L. This one is the short answer if the question is concerning about the marginal product. How much is the marginal product? But if some of the mathematical problem is asking about this one, optimum production, please measure the optimum production of output K and L with we need to calculate using the Lagrange. Okay, we will answer for this. Okay, we have the FKL is 12KL, which is K is 4, PL is 3, and M is equal to 96. Sorry, I have let me have 1 second to record it. And I'm back again. Thank you for your time. Okay, let's answer it. I have to record it with some piece of paper because after this might be I cannot go back to the these questions. Okay, let's try it. First thing first, we need to identify the equation of Lagrange. Okay, equation of Lagrange. If you still remember, the equation of Lagrange consists of production function plus Lagrange, and then plus this one make as the function. So you remember how to make the function? The function is, let's say it's m equal to k per pk, which is l per pl. Okay, but however, this one I make it in here, so it's becoming minus. Okay, so let me make it in here. 4k plus 3l minus 96. Okay, so this is the equations of Lagrange optimum productions. Okay, let me rewrite it again here so you will not forget, including me. Yeah, sometimes thinking that old lady, right, will be forget about it. Okay, plus Lagrange 4k, right, plus 3l minus 96. Okay, we already have this Lagrange, and then we need to differentiate it as the for the capital. So how is the first differentiations? Here we have 12l, right? The first differentiation of k is 12l, plus in here, since we already have these equations, probably I can make it easier. Here is as 4k Lagrange. Let me make it clear. Here is 4k Lagrange plus 3l Lagrange minus 96 Lagrange. Okay, so in here we can change to the what is the first differentiation of this one. So it means for Lagrange, right? In here we do not have the k differentiation, so I think it's already enough. This is the first equations. And then now the second one for the labor. How is the differentiation? Here, of course, 12k plus, and this one, I think no L and only this one. It seems that 3 Lagrange. So we have the second equations. Since we have second and two equations, we are trying to make like Lagrange equal to Lagrange. This one equal to this one. Okay. So how to make it happen? So we can try like this one plus sorry, should be 4L. For Lagrange equal to 12k plus 3 Lagrange. So okay, it would be easier if I put it in here. So it's quite uh, challenging, right? Here, it's not easy to make it like this. So I give you some uh, tips for you. Not doing like this one, but you have to make it. You have to make it in here as okay. 12L plus 4 Lagrange equal to 0, right? Make it like in here. 12L equal to minus 4 Lagrange, and this one put it in here. 12L divide into sorry, divide into minus 4 is Lagrange. This one will be easier. And in this part, let me make another color. And in this part, you can make it like 12k equal to minus 3 Lagrange. Okay. Okay. Let me put it here. 12k equal to minus 3 Lagrange. So put it in downstairs. Will be like 12k divided minus 3 is Lagrange, or Lagrange, sorry, it would be like minus 4k is Lagrange, and this one could be as Lagrange is equal to minus 3l Lagrange. So we have this one, And we have this one. Okay, you need to remember minus 3L equal to Lagrange, and the other is minus 4K equal to Lagrange. Make it Lagrange equal to Lagrange. This one is easier if you want to recognize how to do the answer for the Lagrangian equations. Okay, we can find minus 3L is equal to minus 4K, or L is equal to 4 per 3K. So we already have this equation and put it into the equation of M equal to PK multiplied by K, PL multiplied by L. We have, and that previously is 96 equal to 4K, right, plus 3L. Okay, now we put it in here, sorry, in here. Okay, so 96 equal to 4K plus 3 times 4.3K. Okay, we find it now. 96 is 16 equal to 16K. How much is K? Let me think. 0.6. Okay, I think K is 6, right? I think 6, but yeah, I think that one. So we already have the answer that K is 6, and then put it in here. K is 6, which is L 4 per 3 multiplied by 6. So L is 8. So in this questions, we already know how much is K and how much is L for the optimum productions. Okay, so we already have K equal to 8, L equal to 6. But we need to think, is it optimum or not? If you still remember the optimizations, actually like the previous in the consumption, optimum is mu x equal to px, or mu y equal to py. For the optimum of production, okay, it's also equal to mpk equal to pk. Sorry, mpk divided pk is equal to mpl divided to pl. It has to be in this like criteria. If this criteria is correct, it means that you are having the K and L as correct answer. So we already have the MPK. MPK will be like MPK should be like a 12KL, right? MPK will be like 12L. MPL is 12K. So we can understand 12 multiplied by 6 divided by how much is PK? How much is PK? 4. Is it equal with, oh sorry, is it equal with 12 multiplied by 8? Oh sorry, this one should be 8. 12 plus, okay, sorry, should be 8. Same. This one is 8 because it's 12K. Divide with how much is the L? 3. Is it the same? Okay, you have to think if it is the same, so it is the optimum. You have the K and L optimum, which is K is equal to 8 and L is equal to 6. Okay, that's the end of the optimization for productions. If you want to do the exercise, I will have the exercise in practicum. You should open the practicum, and then you can submit a few works for calculating the production optimization. And again, if you have something problem, you can raise some WhatsApp message to me. And today we will have actually, it should be we have a class again on Monday, but we will talk more in the WhatsApp group. Thank you so much for your time. We will meet you again soon. Okay. Assalamualaikum warahmatullahi wabarakatuh.